Hello, welcome to this episode of creating a linear algebra library in C++. In the last video, we created this matrix class. We learned how to store the matrix dimensions and also how to allocate space to store our matrix data. We initialized the space that we allocated with values of 1. We also displayed the matrix content on the console. One thing we did not do is we did not deallocate the memory that we allocated for our matrix data, which means that the data of our matrix objects that we create are going to remain on the heap even if the matrix object goes out of scope. For example, I'm going to put the matrix 2 into a scope of its own. And because matrix 2 is in a different scope and we don't have access to it anymore, that is why we have this error here. So we can copy these lines into the scope of matrix 2. To test whether the matrix 2 object will still remain on the heap, let's insert a breakpoint at the beginning of our program. I will build and run our application in debug mode. To see data allocated on the heap, we need to enable the heap profiling on the right here. Once the heap profiling has been enabled, we need to take a snapshot of the heap. And opening this snapshot, we can see that the heap is currently empty because we have not made any allocations on the heap. I will execute the current line to the next line by holding F10. And once we create the mat1 instance, that means we have allocated data onto the heap. We can see that the mat1 variable has n rows which is equal to 3 and n columns which is equal to 3, and that is what we are passing into the constructor. When we expand the mat1, we can see that the mat data has a particular address and has the value of 1. This is the first element within our matrix data array. To see the entire array, we need to take another snapshot. And now what we are interested in is the double array which has been stored on the heap. We can see that we now have one double array which has been stored on the heap. If we double click on it, we have our entire array displayed here. And the address of the first element also corresponds to the address of our mat data in mat1. I will execute the next line to create an instance of the matrix 2. Now on the bottom left, we can also see that the matrix 2 has been initialized with number of rows which is equal to 2, number of columns which is also equal to 2, and 2 for the number of tubes. And that is exactly what we are passing into the constructor. When we expand, the mat data has a specific address which corresponds to the first element of our matrix array. When we also take a snapshot of the heap, we can see that the number of double arrays has increased to 2. And when we double click on it, we can see that the current added address corresponds to the address of the mat data of mat2. We can now print our mat2 on the console. And at this point, what we would expect is for the mat2 data to be deallocated. If we check the console, the matrix data is printed alright. So let's leave this particular scope. On the bottom left, we can see that our mat2 data is no longer available, meaning that it has gone out of scope. But let's take a snapshot of the heap and check whether it's still present there. We still have the number of double arrays as 2, and when we double click on it, we can see that the data is no longer available even though it is still present because we did not deallocate it properly. So I'm going to stop running the code since we know that our data is not getting deallocated from the heap. So let's make provisions to deallocate the memory that we will allocate for our matrix data. In our matrix.h file, I'm going to add a function of a void return type which I'm going to call free memory. To deallocate the memory, we first need to check whether we have allocated any memory. Otherwise, we will do a double deallocation of memory and this can cause problems for our application. So if the mat data is not equal to a null pointer, that means we have allocated memory. And to delete the data on the heap, we need to use the delete keyword. What this means that we are deleting an array on the heap. We also need to set the dimensions of the matrix to zeros because since there is no data, meaning there is no matrix dimension. And now with our memory deallocated and our matrix reset, all we need to do is to call this function in the destructor. And what we are saying is whenever an object of this class goes out of scope, we want you to run the free memory function. And now let's test it once again to see whether our math2 data will be deallocated. So I'm going to take a snapshot like we did before. We can see that there is no double arrays currently allocated on the heap. So I will execute the current line and create an instance of matrix 1. We can see that the number of double arrays currently allocated on the heap is 1. And just like before, the address here corresponds to the address of the first element of matrix 1. We've also created an instance of matrix 2, which we can also take a look at it. And now we have 2 double arrays stored on the heap. And if we also look at the address that is shown here, it also corresponds to the first element of the math data in matrix 2. So I'll execute the next lines. And now currently our math2 has gone out of scope. So let's take a snapshot of the heap once again. And now the number of double arrays has reduced to 1 since we have deallocated the memory that we are allocated for math2. And at this point we can see that matrix 1 has also been deallocated and all the dimensions have been set to values of 0. And if we take a look at the heap, there are no doubles allocated on the heap, which means we have successfully deallocated the memory that we allocate. We have been able to solve the issue with deallocating the memory that we allocated onto the heap. Even though everything seems alright, there is a particular issue that arises as we are able to deallocate memory. And to demonstrate this issue, let's open our matrix class and create a static function. I'm going to create a static function of a matrix return type, and I'm going to pass in 2 integer values. This is just a test function which will be deleted after I demonstrate the issue. Static function means that we can call this function on the class without having to create an instance of this class. I'll create this function implementation in our matrix.cpp. In this function, I'm going to create a new instance of a matrix. Basically, I'm going to pass 2 integers which will be assigned to a matrix dimension. And then I will create an instance of this matrix. And what I'm going to do is I'm going to return this matrix from this function. Back to our main.cpp, I am going to create an instance of a matrix which I'm going to call matrix 3. And this matrix 3 is going to be equal to the instance of the matrix that we just created within the function. And we want to create a 2 by 2 matrix. Let's display the matrix 3 on the console. First, we are getting this particular error here. In addition to that, instead of our matrix being filled with 1s, they are just filled with some junk values. So let's create our application now. What is happening is this matrix object is local to this function. And so when this function is executed, this matrix object is deleted because it has gone out of scope. And hence what is returned as a matrix object is just an empty matrix. However, as we develop this matrix class, we would want to be able to return matrices from functions. And for us to be able to do that, we need to create a copy constructor. So we'll go back to our matrix.h file and add a new constructor. And this is how we are supposed to define a copy constructor for a class. It takes in the address of a class object as a parameter. Let's implement this copy constructor. First, we have to assign the dimensions of this other matrix to the variables of this matrix class. So let's do that. Once we have assigned some matrix dimensions to the class variables that we created, we will need to estimate the total length of the new matrix that we would like to copy its values. I am going to use a shorthand if statement to determine whether this is a 3-dimensional matrix. In that case, we would like to multiply the n cubes by n rows and n columns to determine the total size of our matrix. If that is not so, we will only have to multiply the n rows by n columns. We need to determine whether we have already stored data into our math data. If that is the case, we need to delete that data first before we copy the data from the other matrix into our math data. Once we have deleted our math data, we are going to allocate a new space for our math data. using the new dimensions and also the new total length of the matrix that the other matrix possesses. After doing this, we will just have to copy the other matrix data into our math data. To do the copying, we will use this standard library function, which is called copy. We need to copy the entire matrix data of the other matrix, now save it into this current matrix. And with this, we should be able to return matrix objects that we will create within functions from the function. We should also remember to make the matrix parameter, that is the other that we are passing into the copy constructor, as a constant. Otherwise, we will get an error. You should also make that correction here. Now let's test our code and see whether our matrix is getting returned from the function. And there we have it, our two-dimensional matrix 3, which is filtered once, printed on the console. So this really works fine. However, it is quite expensive to reallocate memory that you have already allocated just to return objects from functions. So what we can also do is there is also a move constructor, which we can implement in such a way that we wouldn't have to reallocate memory for our matrix data. We will just move the data from the other matrix into our matrix data. So let's implement a move constructor. The move constructor is similar to the copy constructor. The only thing that changes is the other matrix parameter. In the move constructor, we are going to repeat the same thing we did for the copy constructor. However, we wouldn't have to calculate the size of our total matrix because we are not going to do any reallocation. And here we can right away set our math data to the math data of the other matrix. However, the other matrix data still points to the data that we've moved to our matrix data. So if the other matrix goes out of scope, the data is still going to get deleted. To prevent this, we need to set the other math data to a null pointer. Whilst the copy constructor takes a constant matrix parameter, the move constructor is not supposed to take a constant matrix parameter, because if it is constant, then we will not be able to modify the math data of the other matrix, and that is why we are having this error here. So let's remove the constant, and as you can see, we don't have the error anymore. So if we run our program now, we wouldn't see much difference. However, let's run in debug mode to see which function is being called. We can execute lines by pressing on F10. To step into the function and execute the function line by line, we can press on F11. So I will step into the function, and here I will create the instance within that function. And before we exit this function, let's press on F11 to step into what the compiler is doing. As you can see, the move constructor is being called instead of the copy constructor. So it is going to copy the dimensions of the other matrix into the dimensions of our new matrix. And then it will also copy the matrix data. Once it's done, it's going to return the new matrix object and set the value to matrix 3. And hence when we print it out, we have our two-dimensional 2x2 matrix, which is filled with ones. I think that is going to do it for this video. In this video, we learned how to deallocate memory properly that we allocated on the heap in the last video. We also implemented a copy and a move constructor, which now enable us to be able to return our matrix object from functions. I really thank you for your attention. If you like this video, kindly give it a thumbs up, and if you haven't subscribed yet, kindly consider subscribing to help promote the channel. With this, I will see you in the next one. Bye bye.